Have you ever wondered what happens to your weight when you stick your hand in a bucket of water? Do you suddenly become heavier? It might feel like it, but the answer is a bit more complicated than a simple yes or no. To understand this watery mystery, we need to dive into the world of physics and explore two important concepts: Archimedes' principle and Newton's law. Don't worry, we'll keep it simple and fun. Let's start with Archimedes, a brilliant Greek scientist who lived a long time ago. He made many significant contributions to science and mathematics. Legend has it that Archimedes discovered a fundamental principle while taking a bath. He noticed something fascinating. He realized that the water level rose as he got in, and it dawned on him. An object submerged in water displaces an amount of water equal to the object's volume. This was a groundbreaking observation. This realization became known as Archimedes' principle. It has since become a fundamental concept in fluid mechanics. It means that when you put your hand in water, your hand pushes aside a volume of water that's the same size as your hand. This principle is crucial in understanding buoyancy and why objects float or sink. Archimedes' principle is applied in designing ships, submarines, and even hot air balloons. It helps us understand how these objects can float or rise by displacing water or air. Now, here's where it gets interesting. When water is pushed aside, it pushes back. This pushing back force is called buoyancy. The buoyant force acts upwards, opposite to gravity, which pulls everything downwards. The amount of buoyant force acting on an object depends on the volume of water displaced. The more water displaced, the greater the buoyant force. This is why a giant cruise ship can float. It displaces a massive amount of water, creating enough buoyant force to counteract its weight. Section 4. Newton's Law. A balancing act. Now, let's bring in Sir Isaac Newton and his famous law of motion. This law tells us that for every action, there is an equal and opposite reaction. When you stand on a scale, the scale measures the downward force you exert due to gravity, which we call weight. But when you submerge your hand in water, there's an additional upward force acting on your hand, the buoyant force. Section 5. Putting it together. The case of the disappearing weight. So, does putting your hand in water make you heavier? It's a curious question that many people wonder about. The answer is, not really. In fact, it's quite the opposite. While it might feel like your hand is getting heavier, what you're actually feeling is the water pushing back up on your hand. This is a fascinating phenomenon. Remember, the buoyant force acts opposite to gravity. This is a key concept in understanding buoyancy. This means that while your hand is submerged, it experiences an upward force that partially counteracts the downward force of its weight. This is why you feel a difference. This is why the reading on a scale would actually decrease slightly when you submerge your hand in water. The scale measures less weight because of the buoyant force. Section 6. Beyond the surface. Exploring further. In this section, we delve deeper into the fascinating world of water and its properties. The interplay of gravity and buoyancy explains why some objects float and others sink. This delicate balance is a fundamental principle in physics. Objects less dense than water, like a beach ball, experience a buoyant force greater than their weight, causing them to float. This is why you see beach balls and other light objects effortlessly staying on the water's surface. Objects denser than water, like a rock, experience a buoyant force less than their weight, causing them to sink. The rock's density overcomes the buoyant force, pulling it down to the bottom. So, the next time you're near a body of water, take a moment to think about Archimedes and Newton. Their discoveries have shaped our understanding of the natural world. Remember, there's a lot more happening beneath the surface than meets the eye. The underwater world is full of mysteries and wonders waiting to be explored. From the smallest bubbles to the largest marine creatures, every element plays a role in this intricate dance of physics and nature.